properties each of those segments hold. So again, I'm looking at that very first journal entry. It should say 6.31 on the back of it. It is a trifold. All right. All right, so it looks like this has a diameter, all that good stuff. All right. So today is mainly just a vocabulary day. So should not be too drastic. All right. So first things first, we're just going to talk about some definitions and some basic vocabulary when it comes to circles. Again, some of this stuff you may have already heard before. Some of it may be new to you. All right. So first things first, we have, a circle. Now, before we get started, what I want you guys to do is if you have, yes. Yeah. So what I want you guys to do is I want you guys to grab 6 different colors from the shelf. You just need 6 different colors, trust me, for labeling purposes. So you need 6 different colors. There's color pencils on the shelf. So if you don't have any, go grab them now. I'm telling you right now, you want the different colors. All right. So first things first, we have what an actual circle is. And it's basically a set of all points from a fixed distance which that distance is also known as the radius, from another point, which in this case is the center. So basically what it's saying is that if you, for example, has anyone seen like one of those old-timey compasses, like not like the north, south, east, west ones, but like the ones that they used to draw circles, like with a pencil on the end? So the way that works is part of that compass you would use to plot the center. And then on the other side where the pencil is, you would rotate it completely around that center while holding that center point in place. A circle is just any point that is a specifically fixed distance away from that center point. So the way you name a circle. So for example, this is your circle right here. All right. And what do you think my center point is here? What letter do you think my center point is here? J. So J here is my center. Now, we name circles based off of its center point. So the way we would draw this is that we draw a circle with its center point, and this will be labeled circle J. So it's literally just a small circle with a dot in the middle and the letter or number, whatever, of the center point. Now, let's talk about the two segments in circles that you definitely already know. That being diameter and radius. All right. So let's start with radius. So if we're talking about radius, we're talking about a segment from the center of the circle to a point on the circle. All right. Also, the length of the segment is 1/2 the diameter, which we'll talk about in just a second. So essentially, as long as it's a segment that starts at the center of the circle and ends on the circle, it's considered a radius or a radii if we're talking plural. All right. So on my circle over here, what segment could be considered a radius? Between what 2 points? J and F. So from J to F, it's a segment that goes from the center of the circle to a point on the circle. This could be considered a radius. And we would name it appropriately. So we just put JF and we put the segment symbol across, which is just a line. What's another segment on here that could be considered a radius? JD. So right here, this can be considered a radius from J to D. We label it the same way as we did J to F. And there's one more. What do you think? J to G. So from J to G, that could also be considered a radius. We can label it as such. Again, when it comes to a radius, as long as it goes from the center to the edge of the circle, it is considered a radius, even if it is part of another segment. All right. Now, before we go to diameter, let's look at chord first. All right. I know we're kind of skipping around, but there's a method to my madness. All right. So, with a chord, it is a segment that has endpoints on the circle. So, in other words, as long as it looks like a line that goes from one point to the other, that goes from one end of the circle to the other, no matter where it's from, it does not have to go through the center necessarily. It is considered a chord. So, what segment could I possibly consider a chord on the circle? AC could be considered a chord, but just from the 2 points. So it's not line AC, we're just talking about the segment AC. This could be considered a chord. And we would label it just like we would label a radii, which is the segment symbol and then AC. Can anyone tell me one more chord? There is one on here. GD. So from here to here, if we go from G to D, that is also considered a chord because it is a segment going from one end of the circle to the other. This one just happens to go through the center. And we would name it as such. Well, let's say DG. I don't think GD is something appropriate for y'all to write. Don't worry about it. All right, so it just stands for something that's not child approved. All right, so now that we know what a chord is, let's talk about the diameter. Now, one of these chords that we just labeled is actually our diameter. Which one do you think it is? GD. So GD is also considered our diameter. Why is GD considered our diameter and not AC? What's the difference? GD goes to the center. So that's the main difference between a diameter and just a regular chord. A diameter will go through the center. So a diameter is the segment from the center to a point on the circle. I'm writing down the wrong one, guys. Erase. Sorry, I was writing down the definition for radius. So a diameter is the longest, again, my bad, chord of a circle, and it goes through the center. Also, just to note, how does the diameter relate to the radius? Radius is 1/2 the diameter, so what's the opposite of that statement? Right, diameter is also equal to twice the radius, or twice r. All right, and so naming it, we name it just like a radius or a chord, as a segment, and then from 2 points. Diameter also cuts the circle in half. So if you use the diameter specifically, the diameter perfectly cuts the circle in half. Thus, this side would be considered a semicircle. This side would be considered a semicircle. All right, so the diameter is usually the line that also cuts the circle in half. Yes, sir? Yeah. Now, here are the two words that you probably have not heard in terms of circles. You may have heard this in terms of trig, but not circles, and they're very different. So these two are considered lines, tangent line and a secant line. All right. So a tangent line is a line, emphasis on line. It's not a segment, meaning it can go on forever. That intersects a circle at one point. So in other words, it's just barely touching it. It's almost like it's love tapping it. It's like, oh, bumped into you there. I'm going to keep on going. All right. So what's the difference between a line and a segment? What do lines typically end with? Arrows. So we only have two different lines on here. Which one do you think is the tangent line? Remember, X to M. So right here, it hits at point X, but we need 2 points to name a line. So they have a point later on down the line labeled M, but this is considered our tangent line. So if you look and see, it actually doesn't go into the circle. All right. It just very lightly brushes up against it and intersects at that one point. No other value on that line will go into the circle or hit the circle. It's just that 1 point X. So the way we would name this is XM, but then instead of a line, we put a line with arrows on the end. That represents that it's a line, not a line segment. Boys, we're in our journal doing those 2 journal entries that you guys grabbed from the front. We're doing the first one. Now, the last one is a secant line. So a secant line is, again, a line, not a line segment, that intersects a circle in 2 points. So in other words, it actually goes through the circle. All right, it's a line that actually goes through the circle and has 2 points that are on the circle. So remember, lines end with arrows. So where do you think my secant line is? A to C. So this line right here is my secant line. So the difference between a tangent line and a secant line is a tangent line lightly brushes up against the circle. It does not go through the circle. It just hits it at that 1 point and then just continues on its merry way. Whereas a secant line actually goes through the circle. It just stabs right through it and then it goes out of it. All right. So the chord itself is not the secant. It's the orange line with the arrows. That's the secant. All right, so don't get the chord and the secant confused. They're not the same thing. And thusly, we name it differently. So this is the line AC. So instead of just a straight line, we're putting a straight line with arrows on the top to represent that it's a line. Yes, ma'am. Yeah. Any questions on basic vocabulary with circles? So for my 2 boys, this will be posted later, and I'm taking the video. All right. Now, let's take out the other journal entry. All right. So this one deals with arcs. So that first basics was just to try and get you guys to start thinking about, okay, these are all the different segments. And the reason that is that now we're going to be looking at some arcs and how we can figure out measurements of arcs. So I'm going to look at central angle first. So before I even talk about all these different angles and central angle and minor arcs and major arcs, what is an arc? Can someone tell me what an arc is? What's the difference between an angle and an arc? So when you think of the word arc, what do you typically think of? And don't say Noah's Ark. Like a bridge. And what does a bridge typically do? Like a stereotypical bridge. It goes up and it comes back down. So in other words, it's a curve. So for example, this right here would be considered an arc. An arc is just a piece of the circle, like the actual edge of the circle between points. All right. Now, these arcs can have measures in degrees just like angles. But the difference between an angle and an arc, the easiest way I like to explain it is, let's say I drew an angle and then its corresponding arc. All right. What does that look like to you? Well, what does it look like to you in real life? What could you kind of relate that to? A what? Bow and arrow. It could also be an ice cream cone, however you want to see it. Okay? That's a sad ice cream cone right there, but it's, yeah. So a way you can think about it is if we go with Corey's example, this looks like a bow and arrow. The drawstring is the actual angle. All right, so where you actually draw it back, that's the angle. Whereas the bow itself is the arc. So this is the arc, and this is the angle. Another way to think about it is that the angle comes from the tip of the cone, whereas the arc is the ice cream on top. All right, that's another way you can think about it. Both of them have angle measures, but depending on the type of angle and the arc that's connected to it within the circle depends on its measurement. So today we're talking about the very simple rule, which is the central angles. And these are like the easiest things to do ever. Now, later on this week, we're going to talk about different arcs formed from different angles on a circle besides just central angles, which have their own other set of rules. All right, but today we're starting with the easy stuff. So, when I'm talking about a central angle, I'm talking about an angle formed by two radii. And remember, radii is just the plural of radius. All right. At the center. All right. So, in other words, the vertex of that angle or the tip of the angle is at the center. So, its vertex is the center point of the circle. That's what a central angle is. It is an angle where the center point of the circle is its vertex. And another thing to note is that it has 2 points. The other 2 ends of its angle has to end up on the circle itself. So, remember, when we name angles, we name it in 3 letters, with the vertex being the middle letter. So, can someone name me one central angle? So remember, when you name angles, you need 3 letters, the vertex being the middle letter. Corey, what you got? ACE, good. So, Corey just said ACE is considered a central angle. So if you go from start at A, go to C, go to E. C is clearly our center. So this angle right here is considered a central angle. So this is a central angle. And we would label it as such. So angle ACE. Can someone name me a different one? Landon, what you got? FCE, good. So right here, that could be considered another central angle. So we label it as FCE. Can someone name me another one? Say it again. DCF, good. So DCF is right here. That's also another central angle, DCF. And there's one more. What's the last one? ACD, good. So this angle right here, and I'm using different tick marks, remember, because if they're the same number of tick marks, that means they're congruent. None of these angles are congruent. All right, so that's why I'm using a different number of tick marks per angle, just to show you guys that they're not congruent. And that would be angle E, nope. That would be angle ACD. All right, so those are our 4 central angles that are listed here. Now, with central angles, here's what is fantabulous about them. All right, the arc formed by central angles is congruent. Yes. So the arc formed by the central angle, so the bow connected to the string or the ice cream connected to the cone, that is called our intercepted arc. And what that means is that if our central angle is a specific degree, it is congruent to the measure of our intercepted arc. So another thing to note here is that the measure of the central angle is congruent to the measure of the intercepted arc. And again, all intercepted arc means is that it's the bow to your drawstring. It's the ice cream to your cone. All right. So, for example, if we look at the first central angle that we found, so that green outline angle, our intercepted arc would be right here. All right. So, if this is our intercepted arc, and you can label it as such, because notice how here's our drawstring and here's our bow. All right, they're connected. So if this intercepted arc measure is 45 degrees, so an arc measure is always going to be outside the arc. What's the measure of this angle? 45 degrees. They're congruent. All right. What if we look at this central angle? All right. Its intercepted arc is from D to F. Now, this arc has a measure of 60 degrees. So what do you think this angle measure is? 60 degrees. They're congruent. So that's why central angles are very, very nice, because when you're asked about the measure of its corresponding arc or its intercepted arc, it is the exact same measure. All right. Any questions on central angle? Now, let's talk about how we define arcs. All right. And there's not really a lot of math to this per se. It's more so how we know what kind of arc we're talking about, how we name arcs. So there are two different types of arcs. They're called minor arcs and major arcs. All right. So with a minor arc, it is a portion of the circumference, meaning the outer edge of the circle, of a circle that measures less than 180 degrees. Now, what's so special about 180 degrees when we're talking about circles? So why is 180 degrees pretty special when it comes to circles? What's so special about it? Guys, how many degrees are in a circle? 360 degrees. So how does 180 relate to 360? It's half of 360. So 180 is half the circle. All right. So that means we have to have our minor arc has to be less than half the circle. All right. Now, when we name arcs, we name them using 2 points only, just minor arcs. All right. So, an example of a minor arc that I have would be from A to D. That's a minor arc. Also, the two arcs that we found earlier when we were talking about central angles, those are also considered minor arcs. Because what part of the circle determines where my 180 degrees stops? So this right here is my minor arc. And again, what segment of a circle determines where my 180 degrees stops? How do I know that I've gone 180 degrees around a circle from a starting point? When you get halfway, or in other words, when you get to the other endpoint of which segment? What segment? The what? No. What segment cuts a circle in half that we just talked about? The diameter. So the way you know if you're less than half the circle is that if you can locate the diameter and it doesn't go all the way from endpoint of the diameter to endpoint of the diameter or past that endpoint of the diameter, is considered a minor arc. So for example, my diameter is clearly from E to D. It cuts the circle perfectly in half. Now, from A to D, this little arc between these 2 points, it clearly does not go all the way to E, which is what it would have to do in order to be considered halfway. So if I start from D and I travel around until I get to A, I still have not done a 180-degree turn around the circle. So this is why it's considered a minor arc. Thus, the way we name it is that we name it in 2 points. So from A to D, and we use a little arc over top of it to represent that it's an arc. Another thing to note about arcs, it's that a minor arc is the shorter path between 2 points. Because on the flip side, we have what is referred to as a major arc. So our minor arc AD is a very small part of the circle. However, the part that makes us know that it's going from D to A in the shorter path, because if we notice, we could also get from A to D by going this way. However, isn't that the longer path to go from A to D? Yes. So while this is its minor arc, this pathway would be its major arc, meaning that it's the longer distance from A to D and it's greater than half the circle. So from A to D on the longer side, this would be its major arc. And again, the formal definition of a major arc is it's a portion of the circumference or part of the edge of the circle that measures more than 180 degrees, or again, half the circle. Now, we measure or write out major arcs using 3 of its points. That's what clues us in to whether we're dealing with a major arc or a minor arc. So whether we're going the longer way around or the shorter way around to between those 2 points. Now, to name this arc that I just drew out, the orange arc, you always want to have its 2 endpoints. So we have to have A and D somewhere in there. The other point does not matter because we could choose either E, B, or F. The only difference is that it actually really doesn't matter because as long as it's a point in between those 2 endpoints that is on that major arc, that's any way we can name it. So any way we can name this arc, we could name it the arc of AED. We can name the arc ABD. or we can name the arc AFD. All three of these points, or all three of these names, represent the exact same arc. Because again, it doesn't matter what point we pick in between those two endpoints, as long as it is in between the two endpoints on the big arc. All right. And again, just to note, a major arc takes the longer path between 2 points. So the shorter path is the minor arc. The longer path is the major arc. And then finally, we have the semicircle, which if minor arc is less than half, major arc is more than half, a semicircle is what? Half. All right. So a semicircle, to put it plainly, it's an arc that measures 180 degrees. Just as simple as that. It's measured 180 degrees, and it's exactly half the circle. Another thing to note is that the diameter is typically the segment that denotes the semicircle. So it's typically made from the diameter or the arc associated with the diameter. So a semicircle in this case could be right here. All right, it's exactly from one end of an endpoint of the diameter to the other end. This is our semicircle, and it's equal to 180 degrees. All right, it's exactly equal to 180 degrees. Now, when we name a semicircle, we also, just like a major arc, name it in 3 points. A minor arc is the only type of arc that will only use 2 letters. Every other type of arc uses 3. All right. So again, just like with a major arc, we need 2 endpoints and a point in between them. So one of the ways I can name the arc that actually the only way I can name the arc that I just drew is EAD. What's another semicircle I could create and label it? Say it again. DBE. Good. So we could also say DBE or D. I don't know why I wrote B. Or we could write DFE. All right. So in other words, this side of the circle over here, it's still between D and E, and we could have put either one of these 2 points that's between the two to represent the semicircle. Those are also considered semicircles. In fact, it's the same semicircle. Now that we know all of our definitions, we're going to answer some questions involved here. So we're using what we know, using circle C to find the measure of each arc or angle named below. And we're going to name the arc or angle based on what we know. And like I said earlier, ED is the diameter. So one of these we already found out. We already found out the first one. So the measure of angle FCD. What was that measure? What was that measure? 60, which is right here. All right. Now, what was this called? What's angle FCD called? It's a central angle. All right. Now it wants us to know the measure of AE. Now, am I talking about an arc or an angle here? An arc. Major or minor? Minor. How do we know it's minor? It's what? It's small. What else? How else do we know it's minor? Doesn't go all the way around the circle. How else do we know it's minor? It's the way it's written. It only has what? 2 points listed. So the key into a minor arc is that there are only 2 letters there. That M represents measure. So this is a minor arc, which that's right here. And we already found the measure to that arc, which is what? 45 degrees. And that one was already labeled for us. Now, the measure of arc ADF. Where is ADF? So where would ADF be? First off, would it be a major arc, minor arc, or semicircle? What do you guys think? It's a major arc. Why is it a major arc? It's more than 1/2, but also, how's it labeled? It has 3 points, and just from looking at it, which it's right here, all right, it's right here. It's made up of 3 points, and it looks like it's bigger than 180. Now, we got to kind of figure out what that angle is. So we're going to come back to that arc measure. And the reason we are is that you'll see in a second. All right. So we're going to put a pin in finding that arc measure for right now. At least right now we're identifying. What about the measure of AD? So first off, is AD a major or minor arc or semicircle? It's a minor arc. It's right here. It's clearly less than 180, and it's made up of 2 different points. So this is a minor arc. Now, this value I can find fairly easily. What can I do to find the measure of this arc? Because I'm not given its central angle, but there's something else that I can use. What do you think it is? There's another property that we stated earlier that I can use fairly easily to figure out what this arc is. What do you think I can do? So we know that this minor arc has to be less than 180 degrees. Well, does that arc connect to another arc that would make it equal 180 degrees? Yes. What other arc, if I connect it to AD, makes a semicircle? AE. So right here. So if from D to E makes a semicircle, and we know a piece of it, which is AE, and the other piece is what we're trying to find, how do you think I'm going to find it? 180 minus 45. So to find this arc right here, we're going to do 180 minus 45. And that will give me what? 135. Now we can go back to our previous arc, because if this is 135 degrees, this arc, don't we have all the measures that we need to get from E to F? Or I meant from A to F. My bad. So A, D, F. Don't we have enough information now? Yeah. So guys, don't we have enough information now? Yeah. So what do you think I'm going to do to find the measure of ADF? Add what? Add AD and DF. Good. So we're going to add 135 to 60. So if I add 135 plus 60, that gives me what? How many degrees? 195 degrees. All right. What about angle ACD? So it's this angle right here. What's that angle measure? We have enough information to find that. Don't we have ACD's intercepted arc? Or the ice cream to its cone? Yes, no, maybe so. Come on, guys, verbalize. Use your words. Yes. So, its intersected arc measure is this. What's true about this type of angle? First off, what type of angle is it? It's a central angle. What's so special about central angles? They are blank to their intercepted arc. They're congruent to the intercepted arc. So what do you think this angle measure is? 135. Good. We already found its intercepted arc in one of our previous questions, which is 135. So that means this angle here is 135 degrees. Almost done, guys. All right. So then we have angle ACF. It's obviously going to be a central angle. That's all the type of angles we have on here. But ACF is right here. I don't have quite enough information yet to find it. Actually, no, I do. I do. We just got to kind of go around our butt to get to our elbow a little bit. All right. So if I'm trying to find this angle right here, so in other words, this big angle right here, that's what I'm trying to find. What can I do to find it?
195 from 360.
Where'd you get 195?
We're looking for ACF, right?
Uh-huh.
So we already know that ADF, not ADF. Sorry.
ACF, but on the other side? Yep. Mm-hmm. Right. So, yeah. So Gavin came up with a good point. All right. We know what ADF, that arc is. Its intercepted angle is this big angle right here. That is 195 degrees, which I forgot to label. All right. That arc is 195 degrees. Well, ACF makes up our intercepted arc right here. And that is the rest of the circle that ADF does not touch. So all we got to do is subtract 195 from 360 to get our central angle measure, as well as that intercepted arc measure. So we're going to do 360 minus 195, and that'll give me what? 165. All right. So that being said, arc measure AFD. Let me ask you guys this. If we know that this angle, big angle measure, is 165 degrees, what's this small angle right here? So what's this little tiny baby angle equal to? If I know this big angle is 165. What would this little itty bitty baby angle be? Not 165. This big angle from A to F is 165. But I want from E to F, or this little bitty baby angle right here. Right, 165 minus 45, because we're taking out this piece over here. So if I do that very quickly, that'll just give me 120 degrees. Which means this minor arc from E to F is also 120 degrees. So, that being said, what's the measure of this big boy arc right here? So from A, F to D. So we're finding this big boy arc right here. First off, is that a major arc, minor arc? What do you think? It's major. It's clearly bigger than 180 degrees. Now, can we easily find it? Don't we have all the pieces that we need? Right, we got 45, we got 120, we got 60. All three of these are pieces of our puzzle. So what do I have to do to find that arc measure? So all of these pieces, so 45, 120, and 60 are pieces of the puzzle for this major arc right here. So what do I have to do to find that arc measure? Add 120 to 60 and then add 45 to that. So 120 plus 60 is 180. Add 45, you get 225 degrees. All right. Lastly, we got FDE. All right. So we're going from this F all the way around to E. So it's clearly a major arc. It's clearly more than half. Now, what's so special from D to E? How many degrees would that be? From D to E. It's 180. And then we just have to add on from F to D, which is what? 60. So if I had 60 to 180, what's that degree of that arc measure? 240. All right. All right, guys. So we're going to take a break and then we'll come back. I'm going to look at your Delta math and see if we need to do the packet notes on this, but I think we're pretty solid. All right. So be back by 12:35. Well, I'm tired too, but you don't see me complaining.